thank you all for joining in large numbers. I know that we've been talking about the AI4Life for a while now, and so many of you might be familiar, at least with the introduction part and the motivation behind it and what we are trying to build. I still hope that in this overall session you will hear something new for you. But the introductory part is the introductory part, right? So this is the basics, but I'm also happy to show you more of the zoo in these 30 minutes and all the new features that we have developed, or at least some of them, and then also to answer questions if you feel like there are many other things that we could be doing. I would also be happy to hear suggestions. Right, so AI4Life consortium itself is actually supported by Euro-BioImaging. And so it's the carrier organization, so to say, for an EC Horizon Europe grant. Right? And then I'll tell you a little bit of how we actually got together to form a consortium, and then what we were trying to build with the EC funding and what we want to also do maybe looking ahead. Right, so I am actually a computer scientist myself, and I work on machine learning for image analysis, as do many of the people that work in AI4Life. And the main tool of my lab is called Elastic, right? And so Elastic is actually not based on deep learning yet, not fully, but it's based on what we call feature-based learning. And then in here, so if you think about feature-based learning, just to show you kind of the path that I had to take to come to the idea of AI4Life and the Model Zoo that is its main product, was that, well, if you think about feature-based learning and machine learning in general, right, the big promise that it gives to you is that you go from your images to the thing that you actually want to have. And the only thing that you provide for this is, in a feature-based setting, you think about what could be useful to decide where, say, the nuclei are, like in this image, or where the objects of your biological interest are. And then you also provide a little bit of training data just to show it, yeah, that is what I actually need, right? The way it works under the hood, right, is you could say, okay, we have some features, we have information that is important to decide what pixels you want and what pixels you don't want. So here illustrated with just two, intensity and texture. So if you had that, you project your whole image in there, right? Then if you were living in an ideal world, then you could probably already have two clusters here of your cells and not cells. This doesn't actually happen, right? What you have to do instead is you give some labels. These labels now give you an idea of where to put this boundary in the decision space. Then you add the boundary in the decision space, and then you can actually label all the pixels and you arrive at your segmentation. Right? This works very well up to a certain level of the image complexity. And then once it actually stops working, then you have to go to a deep learning based system. And then if you want to go to a deep learning based system, that is actually what this will look like. And the difference here is that on the one hand, everything got better in the sense that now you don't really have to think anymore what information you need to extract from your images first before you can tell it how to partition the space, right? But on the other hand, now you have a much bigger black box and much more training data that you have to provide, because otherwise it will not be able to both create the space in which the data is separable and then also to find how to separate it, right? And then, well, the reason why we are going for this, despite the increased demands to the size of the model and to the, especially to the amount of training data, is that it works really, really well, right? It works better than anything we ever had. It works better than I hoped anything will when I was starting my career. Right? Another great thing about it is that you can, in the same way as we had with feature-based learning, right, you can train the same architecture, right? You can train the same network to do many different things. So there is more and more separation, you could say, between, in a good way, right? Like separation of work between the people that think about how to train networks and people that actually need to get something extracted out of their images, right? Because what that means is that we can develop our methods kind of by themselves, right? And then we give them over to you, and then you provide the training data, and the training data actually parameterizes the network to do the things that are useful for you, right? So yeah, and then once the network is actually trained, then we know that it's easy to run, right? It's deterministic, right? You just press a button, it actually processes your image and it goes through. I see there are some chat messages coming. Is that people are not hearing me or some other scary thing like this, or is it just questions?
No, sorry. I mean, there are probably some leftovers from the previous talk, so please.
Okay, okay. No, but you will let me know, right? If I disappear suddenly
or
something, okay? Okay, so it's easy to run once it's trained, right? We can train the same thing to do many things. It actually works really well if you train it properly. The problem is, like I said, that the training itself requires a lot of data and a lot of computational resources, right? So the training you really have to do on the GPU. The super big networks that people train for natural images now train for thousands of GPU hours on arrays of thousands of GPUs. And then also, when you have a new problem that you want to solve, right, there you also kind of need to know what you're doing. If you need to change the laws, if you need to change the architecture, if you need to think about how exactly to present your data to take advantage of the architecture of the network. I mean, all of this actually requires knowing what you're doing. And yeah, and so then what we thought of, me and Vey and Florian and the others on the team, Arate and Esti and Ricardo and Matthew, is that, yeah, so what people actually need is a way of how you could take a big pre-trained model and bring into the end user software that the biologists in the field actually use, and then run them there without the code. Because this way, if the model is already pre-trained, you don't have to provide a lot of data. Right? You don't need that much computational resources if it's already trained as well, right? So like many of you who have already tried running microscope-specific networks know that even on a CPU, right, you can get a reasonable response, right, for images that are not too large. Right? And then, like I said, when it's trained, it's completely deterministic. So you can just run without code in a single button thing. Right? And then, well, when you think about this, there are a lot of tools in our community, right? A lot of people developed specific applications to solve their problems, to scratch their itch, and then the best of them actually survive and like float to the top. People have their preferences. And I think it's a great community, and there is no reason to put in yet another very big tool that will do something that others already can. Right? So people have reasons for their preferences. And what we thought about is that, well, what we need is not another tool, but for all these pre-trained networks to have a shared format that is actually understood by all the tools, right? In such a way that if I want to provide my Elastic users with a tool, with a pre-trained network, I don't have to necessarily pre-train it myself. Right? If someone else in the community actually pre-trained a great network, I just want to be able to run it. And other people that also provide user-facing tools have agreed with us and decided that, yes, this would be a good idea. And this is how we started to work on the metadata standard for sharing pre-trained models, right, in a way that would be actually appropriate also for models that are trained to process data from biological experiments. Right, so if you want to think about, well, what is even there, what's in that metadata, well, you can get it, you can go very deep and make it like a very, very big format where everything has to be specified, or you can try to make it absolutely minimal and just specify, say, the author's name, right? So our main objective was really to build it in such a way that that the user doesn't have to write code to run the networks, so that it could be, very straightforwardly embedded into the user-facing tools like Elastic or DeepImage. Right? So a pre-trained model, what it has to have, what you need to be able to execute it is like you need to know the architecture and you need to have the layer weights that the training has converged to. But also for bioimages, there are some other things that you need to know, right? Such as the input shape, right? The output shape. How was the input normalized, or how do you expect the input to be normalized? Is there any pre-processing? Is there any post-processing? Pixel size, right? Other important information like that people in natural images don't really have. And also, if you were working with this data programmatically, things like input shape or output shape, you could just look up in the code, right? You can see what the network expects, and then you write your own data loader, you put the images in there, and then it processes. But since that was exactly the step that we wanted to hop over, right, that's what we now need to specify in the metadata. So, the standard is now in its version 6, right? And it's developing as a community process. If any of you are into training networks, I would be also very happy to get you involved, right? So it's a very open way in how all of this is happening. And there is also the shared website, right? The BioImage Model Zoo that collects the networks that have the, and I will also show it to you, right? That collects the networks that all follow this metadata format. And there you can take the networks for many different tasks, download them for your favorite tool, and then do things with it. So when we came up with the idea that maybe our community actually needs a BioImage Model Zoo, and with the first version of the standard, we then applied for a grant in Horizon Europe, right? And then our consortium called AI4Life was formed, right? With the main goal of actually now bringing together the computer science community and the life science community in the sense of, there are many people that actually train models, and there are many people that need models, but still there is this bit of a divide, right? And one of the ways we wanted to address this divide is by providing then the model format in which people that train models but don't want to develop the GUI tools for them could just make them available. And then if anyone who trains a segmentation model can now save it in the Model Zoo appropriate format, and then their users will be able to, for example, run them in Elastic and get their images segmented this way. Right, so we thought that this would be like a nice way to bring the communities together. But then we started thinking further and realized that, well, we actually there are a lot of components that come into this, right? So there is the standard of the pre-trained networks, but there is also the libraries that go with the standard that allow the tools then to read the networks and execute them on new data, right? So there is this whole like infrastructure that has to live around this, and to enable people to actually to put their networks up into the zoo in the most convenient way possible. And then on the other hand, yes, we also need to have the tools for the user-facing tools that they could incorporate inside. And then also one of the bigger questions that we wanted to address was to think about what are the problems of bioimage analysis that we could address in a reasonable amount of time with a community that actually has enough motivation to provide us labels and guidance about what it is that they're trying to extract out of their images. Right, so this idea grew into the whole open calls and public challenges project that Mehdi will tell you about after the short break. Right, and the Model Zoo itself and the infrastructure around it for contributing models, creating models, actually running the models is something that you will see in the talk directly after mine. And I'll just show you maybe some more introductory things about all of this. And then, yeah, also, as you know, since I said that we need a lot of training data to train these models, and this is where also the BioImage Archive comes in, which will be, I think, the last talk of this session, because they want to collect the AI-ready data. And then, you first start thinking about, oh, well, we'll just store the training data somewhere. But then somehow it also grows into a much bigger thing. And you realize how many things you can do when you have a nice collection of AI-ready data, but then also how much you still have to work on the shared understanding of what is AI-ready data. So all of that in Therese's talk, right? And I'll just continue on the AI4Life offerings and the zoo itself. Right, so yeah, so what we wanted to achieve was to have a collection of fair AI models, also growing collection, the one that is really open to the world and other people to submit, right? So we wanted to have more of a bazaar setting rather than a highly curated set of models that we train ourselves, right? So we want to democratize AI for bioimage analysis and enable more people to run good models on their data that would allow them to, to surpass the bottlenecks that come from the common image analysis tasks especially at scale. But then in addition to that, we also, or not in addition, on the way to that, we also wanted to build a community of people that work in this space that try to solve bioimage analysis problems with AI, to enable more collaboration directly between the method developers and biologists, and also think about the future of bioimage analysis and where it will go. So to get the fair AI model sharing happens through our website. Right, and this is a website that is trying to solve 3 problems at once. And I'm not sure how well we are doing either of them, but we are trying. So your feedback is very welcome about if you feel like you can find things on the website or that it addresses you. Right, so we want to address, on the one hand, researchers in the life sciences that have a one-off need, just want to find maybe one network for a tool they know how to use. Image analysts that actually run a lot of things and want to use many different tools, maybe also write their own pipelines, right? And use some of these networks programmatically, but then also method developers that would then upload their models to make them accessible to everybody. Right, so how do you actually create a model that could be uploaded to the Zoo? Right, so we have a very easy GUI that is also documented on the website, right, that you can install locally. We also have the uploader that allows you to also just easily fill out all the fields that we need. Because like I said, it's all metadata. So once you actually have your network trained, then everything afterwards is just providing the options of the things that people will need to understand what it is that you have done. Because if you think about it from the user perspective, there are a lot of things that that need to be known about the model to make sure that people are using it responsibly. Right, so it's good to have documentation about how it can be validated, right? About the metrics that can be measured on top of this data, all of these things. right? And then, so we have, I think, a pretty convenient way of how you can provide it. So if you have trained networks yourself, try it out, get in touch with us. We'd be happy to help you upload them. Right? And then we also host the models themselves, right? So there is the spec, there is the website, right? We used to store them all on Zenodo. Zenodo then changed their terms of service, so we had to go around this. And now we actually have the S3 storage that is hosted at EMBL EBI. So it is self-hosted, but we also mirrored things to Zenodo so that we could, because we don't want to provide the DOIs ourselves, but Zenodo provides that. Right, and so, but now the link actually always goes through our storage and not through Zenodo. Right, so like I said, all the development is actually very open. You can join us on GitHub if you want to contribute. If you just want to contribute a model, you don't even have to join us on GitHub. You can just upload it. But if you want to also play with the spec, make your suggestions about fields we are missing, tell us about problems in the libraries, tell us about other problems in our resources, then you're very welcome to find us in the BioImage organization. Right, so the models in the zoo are presented in these little model cards, which is the way how we digest all the metadata that you have provided about the model and then display it to the user. We'll look into this a little bit more when I actually show the zoo. Right, and then what we also really wanted to have is like a whole reproducible ecosystem where for every model in the zoo, you know how to run it because it runs with the standard library that comes with the format. Right, and that means that all the results that you have in there, you can now reproduce in your own code. So you can take the data from the test images or from the images that were provided with the paper, right? Immediately run it in, say, in Jupyter, right, or in your own notebook on your own resources, right, or actually somewhere remote. Build it into your tools, right, and you can see that it will run in exactly the same way as it did when the paper was done. We also have a chatbot, right? That was an interesting side project that people got excited about and then decided to put out as a way to provide user support around how you find things in the zoo and how do you process your images with this kind of models. Right, so it's based on GPT-4, probably also since it goes through the API from OpenAI. I guess the baseline model is also improving. Right, and it's trained on the community documentation for not just for the Model Zoo, but for all the popular tools. Right, and then also the model cards of our models and the documentation that we have ourselves. Right, so you can. I actually gave the GitHub link there, but it's also easy to find on the website. Right, on the data side that you will hear about Teresa. Right, it's I'll just say, show you one slide about this. Right, so we know that it's the image annotations are actually what make the training happen, right? And they are also very time intensive to produce. So it's really, really important for people to share their data, but especially to share annotated data, right? And then we have some ideas about the standards of how these annotations need to be done for bioimaging data so that we can train in the best, most efficient way. Right, and then, yeah, so there is also the AI-ready image data gallery and the way to explore how the AI-ready data sets can then come together with the models of the zoo and see what can happen when you can actually have a lot of data sets and a lot of models and cross-evaluate them and develop more tools that come on top of this. Right, in general, for retraining and fine-tuning, right, so our idea was, for the beginning at least, to provide only the inference infrastructure, but of course people also want to fine-tune. The problem is that it's very hard to fine-tune an arbitrary network without looking into the code, right? Which is why people still have to look into the code a little bit, right? But if you think about the popular ways of how you can operate with the notebooks of networks that someone has pre-trained for you, and now you just want to go and in a nice supported way, handheld, replace their training data with your own images and create again a network that is compatible with the Model Zoo so that you could upload it. You can do it in Colab through our partner tools BioPy and Zero Cost DL from MIC. Right, and you can also do it if you don't like Colab or if you have a problem that is bigger than Colab. You can also do it through just an open container initiative of the DL for MIC everywhere approach that I guess you will hear more about from ST. Right, in my last 2 minutes, I actually just wanted to maybe show you the zoo itself. Right, so this is what the Model Zoo looks like now. Right, so on top, it just tells you what it is. Right, so here you can see the community partners. Right, so this is all the tools that actually support working with our model format. Right, and I hope you can see your favorites in there. If you can't, then yeah, talk to them that they should maybe join us. Or if you're a tool developer yourself and you want to join this great group, you see we have this plus button. So just reach out to us. We'll tell you how to get on this list. So this is still like what we call the old website, right? There is also a new version available. I'll show it to you later. Right? But what it looks like now, like the current thing, is we have model cards, right? So these are all the models of the zoo. You see, they all do very different things. There are actually 5 pages worth of them. I think they are ordered by the number of clicks, but this number of clicks is also not very fair because some of the models are used in automatic validation workflows, so they are actually clicked more. So, which is why we recommend you to not just look at the most popular ones, but then use the tags of the problem that you might want to have, such as, I don't know, nuclei, right? And then you can see all the models that actually do concern nuclei here. Or you can go for segmentation as your other word if you don't want to have image restoration models. And here you will actually have the nuclear segmentation models, right? And you see some are 3D and some are, well, this, I think it's a 2D studies model. That's also a 2D model. There is one for EM. There are some for light microscopy. This is actually from the Human Protein Atlas images. If you just want to, randomly look at what is in one of these cards. Let me move that. Yeah, so you see all these models, they have an ID that comes from Zenodo, right? So that's why we still have this connection. It has an animal name because the Zenodo DOIs are just very hard to remember. And by this animal name, you can actually call them from the partner tools. Like in Elastic, if you want to run a pre-trained model, you can just say, I want the modest octopus, and then that's what it will give you. Right, so this is you see a 3D nuclei instance segmentation model, right? It has a bit of documentation of how it was trained, right? On like which data sets, what is the underlying architecture. Yeah, you can test the model with your own data. I won't show it to you here because it's a 3D model, but we can try in a 2D model afterwards. You see, you can also talk directly with the authors, right? And communicate with them about things that are not working for you. Right, let me take a 2D model so that we could actually try it out in the browser. Yeah, so you see here is another one, the UNet, right? We can do and then here what we wanted to get here is like a quick way for you to just upload an image and like load some, so in this case, I don't want to upload my own, so I'll just take the sample image that people have uploaded with the network, right? And then run the model on it and see if it will produce a sensible result. Right, and that is what you can see now comparing them, right? So it's, you see, this is the boundaries, right? This is the semantic prediction of the insides of the nuclei. You can now post-process it to actually get an instant segmentation, right? And I would say it works pretty well here, but this is also the test data that people have used when developing the model. You can also do it on your own and see if you would be happy with this kind of quality. Obviously, you can also download it and then do things with it there. So this would be the new website, right? As it's happening now, right? It's you see there we also have models, but now they are ordered differently because the all download numbers we are not counting. But you see, it's also all the same models, also for very, very different tasks, right? So we have EmbryoNet here again, the 3D nuclei, super resolution models, 3D net, Arabidopsis ovalis, some more. And in here, the model cards also look a little bit different, right? So you see we have like some information here, views, downloads, citations, right? The tags that you could use to find it, right? The documentation, but it's not fully ready yet. So that's the website that we are working on now that we will actually show to you later, right? So if we now go back to this one, if you really want to explore it some more, right? We have a lot of documentation that Katerina has so faithfully written, right? So you can see how to navigate it, right? So how to get started, how to use the zoo itself, how to contribute the models, if you're into that, how to contribute things that are not the models, tools, resources, code of conduct, if you care about our code of conduct. So yeah, that's what it looks like now. And after me, you will actually hear from the people that are developing the infrastructure side and other useful things that will allow you to have fun with this.